Hi, welcome back for this session of biology, and here we were discussing about properties of water. We looked at how hydrogen bonds bring about different properties of water. Today, our main idea is on many compounds dissolve in water. Many compounds dissolve in water. So as you can see here, we are having a diagram or a picture of what we are calling a solution. And inside the solution, we have the solvent and we have the solute. So basically what makes up a solution is a solvent and together with a solute. So we will base ourselves, we will look at how this really happens. We will try and see what brings about this. As you can see here, from this video, you can see that what we have here is in fact a polar water molecule, which of course has a positive charge and a negative charge. And here we have a sodium ion and a chloride ion also having the same, having the positive and negative charge. So what happens is that to break up a sodium chloride molecule, what water molecules do, the hydrogen positive ions come and attach themselves to the chloride ion, which is negative, and then pull it apart from the salts or the sodium chloride. As it does that, it breaks down the sodium chloride into its parts, and we end up having what we are calling a solution. So when we are doing that, what we have here is that we will be having two things here which we will look at. And this includes, one, we have the solute and the solvent. So we want to learn, or we want to know in details what all these things entail. So molecules or ions cannot take part in chemical processes inside cells unless they dissolve in water. So unless they dissolve in water, molecules and ions cannot take part in chemical processes, take part in chemical processes. So it is very essential for molecules to dissolve in water in order for chemical processes to take place inside cells. So it means that inside cells we need to dissolve these materials in order for chemical processes inside cells to take place. Chemical processes may include respiration and all the other chemical processes that take place in cellular level. We will be looking at what is the composition of a solution. So what we have here is the solvent. The solvent is the substance that is present in the greatest amount and is the substance that dissolves the solute. So in this case, if we are having water and salt, then water is in fact the solvent. And a solute is the substance that dissolves. So the solute here, in our case, we have salt. Salt will be the solute. Salt will be the solute. So a solution is basically a mixture. A solution is a mixture of substances that is the same throughout. Is a mixture, a solution is a mixture. A solution is a mixture of substances it's a mixture of substances that is the same, throughout. So because it's the same throughout, we refer to it as being a homogeneous mixture. A homogeneous mixture. So as we were looking at the video, you could see clearly that what we had is in fact nothing but, you can see what we are having here is what we are referring to as being a homogeneous mixture. So when it reaches a point where all the particles of sodium chloride are broken down and they mix together with the particles of the water molecules, then in that state we say that it is homogeneous, and that is what we are referring to as being a solution. That is what we are referring to as being a solution. So a solution has two parts, as we saw. It has the solvent, which is the substance that is present in greater amount and dissolves the amount of substance, and a solute, which is a substance that dissolves in a solvent. So the amount of solute dissolved in a certain amount of solvent is a solution concentration. The amount of solute dissolved, in a certain amount of solvent, is a solution's concentration. So in this case, the amount of salt that is dissolved into the solvent, which is the water, will be what we are referring to as the concentration of the solution. The more the salt or the solute, the higher the concentration. The more the solute, the higher the concentration, and the reverse is true. So the liquid part of your blood, for example, called plasma, so blood has plasma. The liquid part of your blood, which is plasma, is about 95%. Is about 95% water. Is about 95% water. So you can see how essential water is in this case, because water is a polar molecule which dissolves all other molecules by attracting among the molecules of other of the solutes, so that it will be able to pull them. So we say that molecules dissolve in water because the attraction among the molecules of solutes is greater than the attraction among the molecules of the solute. Ionic compounds such as sodium dissolve in water because the charges of water molecules attract the charges of the ions. So the charges of the water molecules attract the charges of the ions. So the water molecule surrounds each ion and pulls the compound apart. So it's the same way we saw in the video. The water molecule surrounds and pulls them apart. Some compounds, we'll go to the next part. In this part, we will be looking at first, some compounds will form acids, and as they form acids, we will be looking in details how this happens. We'll be looking in details how this happens. We will be looking in details how this happens. We are having here, we'll start first of all by describing what it means. So some compounds break into ions when they dissolve in water. Some compounds, sorry for this. Some compounds break up into ions. Some compounds break up into ions when they dissolve in water. So when they do dissolve in water, they break down into ions. When they do that, for example, an acid is a compound that releases a proton, which is a hydrogen ion, when it dissolves in water. So an acid is a compound. An acid is a compound that releases a proton, where the proton we are talking about here is a hydrogen ion, which is positive. That is why we are calling it a proton. When it dissolves in water, when it dissolves in water. So if we look at the video here, you will see that what we have, here is a water molecule, as we saw previously, that this part is more electronegative and this part is more electropositive. So we end up with partially negative portion and partially positive portion of the water molecule. This, we said, creates bonds between water molecules which are hydrogen bonds. So the water molecules are joined together. But with the presence of these ions, as we are saying, these ions will break these water molecules. So we have said some compounds break up into ions when they dissolve in water. So if we put these compounds here, they will break down into ions. Let's look at what happens here. So here we are having this compound plus a molecule of water, this compound plus a molecule of water. So you have here acid, where you have water, and you have another compound. You have water. So in general, what happens is that as you pour a substance into water molecule, what happens is that that substance will normally break up, its ions will break down and form new compounds. So we are having this compound here which breaks down as it joins the water molecule, so that we end up with H3O, which is a carbonate. This carbonate is in fact what increases the acidity of water. So what determines if an acid is strong or weak is basically the amount of these ions that will join the the H2O to form these hydroxyl ions. So the more the hydroxyl ions, the more acidic will be the compound, the more the acidic. So if it is negative, then it will be less less acidic. And if it is negative, it will be, if it is positive or a proton, it will be more acidic. The same applies to hydrogen. The same applies to hydrogen. So the same applies to hydrogen. What happens here is that an acid increases the concentration of hydrogen ions in a solution. An acid increases the concentration. An acid increases the concentration of hydrogen ions from a solution. Hydrogen ions in a solution. So if we have more hydrogen ions, then the solution is regarded to be more acidic, and if we have less hydrogen ions, then it is regarded to be less acidic. Bases, on the other hand, bases on the other hand are compounds that remove hydrogen ions from a solution. So bases are compounds that remove hydrogen ions from a solution. So when they remove the hydrogen ions from a solution, then they are reducing the concentration of those hydrogen ions, and therefore also reducing the concentration of the acid. And it continues becoming more dilute until it reaches a point where it becomes, of course, we regard it to have been changed from acid and neutralized. So it will be neutralized. So it will come from up being acidic, then into a neutral state, and down into a base. So we are saying here that when a base dissolves in water, the solution has a low hydrogen concentration. So solution's acidity or hydrogen ion concentration is measured by the pH scale. A solution acidity or hydrogen ion concentration is measured by the pH scale. Is measured by the pH scale. Most organisms, including humans, need to keep their pH within a very narrow range, about 7.0. So most organisms they normally keep their pH concentration at about 7, which we are regarding as being neutral. But some organisms can go to an extreme. Some organisms can go to an extreme and thrive in acidic environment. Like, for example, the azalea plant. Azalea plant thrives at a pH range of 4.5. This is acidic soils. And microorganisms called pyrocrolias, pyrocrophilus survive best at extremely acidic environment. acidic environment. With a pH of 0.7, with a pH of 0.7. So for all these different organisms, pH must be tightly controlled. For those that require acidic environment, they will ensure that they maintain the acidic environment. Imagine if it happens that an organism like us, for example, humans, come in contact with an acid of pH 0.7. This is deadly. This is deadly. We cannot even survive this extreme of acidity. We will be destroyed. The body of organisms have one way of controlling or maintaining this balance. The body of organisms have one way of controlling this balance, and they use what we call a buffer compound. So a buffer is a compound that can bind to hydrogen ions when the hydrogen concentration increases. So they use a buffer. So they use a substance called buffer. So a buffer is a compound. A buffer is a compound that can bind to an hydrogen ion, when the hydrogen ion concentration increases. When the hydrogen ion concentration increases. So when they increase and can release an ion, hydrogen ion, and can release a hydrogen ion, can release hydrogen ions when the hydrogen ion concentration decreases. So we can take these buffers or as being lockups of hydrogen ions that help maintain homeostasis. So these ones will help maintain homeostasis. Just like if you had a bank account, then the bank account will be helping you when you need to get to keep your money. So you can keep your money in the bank account, and when you need money, you will go to the bank and demand for your money, and you will be given back the money. So that is what the buffer solutions compounds do. This is how a pH scale looks like. It runs from 0 through 7, which is neutral, as we said. So from this way, it is more acidic. So when we are saying 0.7, it was somewhere here, and this point is extremely acidic. So the acidity reduces as you move towards neutral, and after neutral, it starts to become basic and more basic up to pH 14. So blood pH is at about 7.4. So bile pH is about 8 and 9. But the stomach acid is about the range of 1 to 3. And pure water is at about 7 pH. So the concentration of ions varies depending on how acidic or basic a solution is. The more concentration of hydrogen ions, the more acidic and the less concentration of iron, the less acidic. So we will stop here for now.